Justin Hudson just entered. Good morning, Saturday Academy. There are 34 students present today. I'm sure we'll have a few late arrivals. Anyways, good morning, happy Saturday. Today is October 17th of 2020. Now we got up to 2035. Thank you so much for all of you that decided to wake up and share my Saturday morning with me. It means a lot that you came here, that you're dedicated, because hard work pays off for math, and it definitely is showing for those that are present right now. Maybe those that couldn't make it will come on later at some point and watch the video. Today, a few things, a few announcements before I begin. Make sure iReady is completed. You should have 120 minutes by today. If you do not have 120 minutes by today, now we have more, 35 students, you need 36. You need to make sure that you get your 120 minutes in. Some of you counted Monday as a day, although Monday was not required. If you did it, great. If not, 120 minutes is due by today. I will be shouting it out. I gave you the email address of who to email if you have an iReady issue. Adam, we'll talk after. Also, we're going to be doing dividing decimals today, which is the keep, change, flip, or keep, change, reciprocal. So when I present my screen, this is the order it's going to go. We're going to have Leanna read the learning target, the lesson notes. We're going to have Anaya, you're going to do model problem 1. Daniela, you're going to do model problem 2 with my guidance. Got it? All right, I'm going to go share my screen now. Here we go. Oh, it closed my window. That's weird. Let me try again. I'm going to go into Google Classroom. I posted it like 2 days ago. I made an adjustment today on a problem. I didn't really like the way it was written, so I went in and adapted. For anyone that did print it out, I'm sorry, the packet is going to be a little different. I made a few changes. Okay, Daniel, you are in the Zoom? Here we go. Guys, got to be patient. Oh, wait, that's the wrong thing. Here we go. This is the work. Please take notes. This is going to help you on Monday when we do dividing fractions. Okay, you guys are going to be ahead of everybody. You're going to know what to do. So it should be a piece of cake on Monday. All right, here we go. Remember your orders. All right, we're just going to omit. Oh, Justin Hudson's in. All right. All right, Leanna, we're going to read the learning target and the vocabulary stuff. Go, Leanna Sanchez. You're up first.
Says learning target. I can interpret and compute quotients of fractions by using visual fraction models and equations to represent problems. Sorry, it's like I have trouble reading sometimes.
That's okay. I'm doing lesson notes.
Lesson notes. Today, Becca Spartans, we will be reviewing division with fractions and visuals. We will go over old Common Core questions and practice our skills of annotation by using the ARMS, A-R-M-S, important vocabulary words. Quotient is an answer to a division problem. Multi-captive. Inverse, a number is the multiple.
Wait, it's a hard one.
Multiplicative inverse of another number if the product of two numbers is 1. Reciprocal, the multiplicative.
Multiplicative inverse. I got you.
Multiplicative inverse of a number with fractions, the numerator and denominator are switched. Steps on dividing fractions. Keep the numbers. 1, keep the first number fraction. Number 2, change the division sign to a multiplication sign. Number 3, do the reciprocal of the right side flip. Number 4, multiply the numerators and simplify if needed. Okay, so like the reciprocal is like, let's say if like you have 1 over 2, basically then the reciprocal for that fraction is going to be 2 over 1. So that's the reciprocal.
Because what you guys are doing is when you do the reciprocal, which I'm going to show you in a second, it's always going to equal 1. So thanks, Leanna. So I'm going to go over this part and then I'm going to have my 1 and 2 problem. Dividing fractions, let's look at this because you're going to use the KCF method in today's work. We got 3/4 divided by 2/7. We use K means keep. So when you see it in the work, the K is keep. I keep the first fraction. So it's just gonna be me on here. So I'm gonna keep this. Okay, I'm keeping the 3/4. What I'm gonna do next is I'm gonna change the division sign to a multiplication sign. Pay attention. 2/7, as Leanna just said, we have to do the reciprocal. The word reciprocal means you flip the fraction. Reciprocal means flip. So 7/2, but so 2/7 is the same as 7/2. And then I'm going to multiply my numerators. So 3 times 7 is 21, and 4 times 2, which is the denominator, gives me 8. So 21/8 is the new answer. So when you're dividing fractions, you're making it a multiplication sentence, which is what Leanna read here for the multiplicative inverse. Now, when that happens, when you do the reciprocal, if I was to multiply, okay, I'm just going to show you here, the reciprocal of 2/7 is 7/2. Let me show you why that's the reciprocal, because here it says that the multiplicative inverse is always equal to 1. You multiply your numerators, which are your top numbers of a fraction. 2 times 7 is 14. 7 times 2 is 14. When I divide 14 by 14, guys, I get 1. 1 is a whole number, which represents the multiplicative inverse, which is the reciprocal of a fraction always has a product of 1. I'll say that again. The reciprocal of a fraction always has a product of a 1. Please write that down. The reciprocal of a fraction always equals 1. Please write that down. Very, very important. I need you to understand that aspect. I don't know if I could drag this up. There we go. Okay, you got to know that. The reciprocal of a fraction always equals 1. So somehow make sure that that is written on your paper. I don't care where it is. I'm going to move on in 3, in 2, in 1. We're going to move on. All right? Okay. Model problem 1. If I asked you to read that, come off mute and please read it for me. You know who you are.
Mr. Dennis, the art teacher, has 2/3 gallons of paint to pour into container. If he poured 1/8 gallon of paint into each container until he ran out of paint, how many containers have paint in them? Include the one that is partially filled.
All right. Leanna, not Leanna, Anaya, can you please reread that problem one more time?
Mr. Dennis, the art teacher, has 2/3 gallons of paint to pour into containers. If he had poured 1/8 gallon of paint into each container until he ran out of paint, how many containers have paint in them? Include the one that is partially filled.
All right, so so keep saying Leanna. Anaya, what is the first fraction we're going to keep? How many gallons of paint is he pouring? Holy cow, we're at 20 students. Go ahead.
1/8.
1/8. So we are going to, but it says Mr. Dennis, the art teacher, has 2/3 gallons of paint to pour into containers. So what's the total amount of paint that he's pouring into containers?
2/3.
Right. So we're going to keep the 2/3. So it says, what fraction do we keep, guys?
2/3.
Okay. I'm going to write in, oops, sorry, because
Mom,
I'm going to use
I'm on mute.
2/3. Okay, we're keeping the 2/3. What does the division sign change to, Anaya? The opposite of division is what?
Multiplication.
We're going to write multiplication on the line. What is the fraction we're going to flip, or we say in math, the reciprocal? So when you guys say flip, I want to hear the word reciprocal. So what fraction are we going to flip or do the reciprocal of?
We're going to flip 1/8 for the reciprocal.
All right, so now that we understood that, we're going to keep 2/3. This is how we do it. We keep the 2/3. We're actually starting, this is what it starts with, right? Before we start doing the work. We're just writing exactly what we wrote on the line. We write the exact equation or algorithm. Now I'm going to show you what it looks like. Anaya said we keep the 2/3. See, keep 2/3. So I'm going to write that in purple. 2/3. She said you change the division to a multiplication. She then said now, I'm going to use the black to show you. The reciprocal means you flip. So you're going to do the reciprocal of the second fraction, which is what, Anaya?
1/8.
But do the reciprocal. Flip it.
And now it turns into 8/1.
8/1. Remember, 8 is the same as 8/1. When you have a whole number like 6, guys, to make that a fraction, you put the denominator over 1. If you have 9, it's 9/1, and so on. So now, all we have to simply do is we have to multiply the numerators. So what are the numerators here, Anaya?
The numerators are 2 and 8, and the denominators are 3 and 1.
Okay, so 2 times 8 over 3 times 1. So help me out. 2 times 3 is what?
2 times 8 is 16, and 3 times 1 is 3.
Okay, now, what kind of fraction is this when the numerator is greater than the denominator? Is it
Improper fraction.
good? So because it's an improper fraction, we have to convert this to, look at the answers. What kind of number? A mixed number, right? So what operation is fractions?
Division?
Good, so we have to turn this into a division, right? We're gonna take this improper fraction and we're gonna convert it into a mixed number or a whole number by using division. A fraction is division, guys. A fraction is division. How many times, huh?
The sign even, the division sign even symbols the fraction sign.
Correct. How many times does 3 go into 16?
15. No, 5 times.
Right, 15. What's my leftover?
1. Remainder
1.
1.
So the remainder, which is 1, becomes the numerator, and the divisor becomes the denominator. So 5 1/3 now. Does everyone see how I got that?
Yes.
Anytime you have improper, you have to do division to convert it to either a mixed or improper, okay? So 5 1/3. Now we go back to the question. So we have 5 1/3. That's what we got. Include the one that is partially filled. How many containers? Does he need 1? Does that make sense?
No.
No. Does he need 3?
No.
No. Okay, so it's either 5 or 6. Which one do you think it is?
I think it's 6 because on the side it says include the one that is partially filled.
Bing, bing, bing. So she's correct because as we just showed you, 5 1/3, we have 5, right? So if I draw this out, I'm going to show you with squares, right? 1, 2, this is what we have, 3, 4, we have 5 here, and then I'm going to add a 6th one. So we have 5 of these that are fully, right? This is, it's not going to let me write on it. So we got 5 of these guys, right? 1, 2, 3, 4. I'm taking a little extra time on this one. 5. There are 3/3 in a whole, guys. So look, 1, I'm going to divide this into 3. And this would represent the 1/3, right? So here's my 5 containers with the 1/3 filled, which means, as Anaya said, you have to include the 1/3. I have to include this one that's partially shaded in my answer as it asked me in the question, and this is from 2016. Does everyone with me? Thumbs up if you're with me. This is a very big class today. I'm very proud of all of you that showed up. Thank you. Let's see. Hey, David, I need you to wake up because you're going to do the 3rd problem. Isabella, camera love. I know 2 of you have cameras that don't work. You're the only 2 that don't have your cameras on. I don't see everyone behind their screen, and I'm a little concerned. Angie, you're doing the 4th problem, so get ready. Are we good? Yes? All right, I'm going to erase this now. I hope everyone is writing their notes down, as we've been telling you in class, because writing it helps you learn the information. Remember, when you have a whole number, to make it a denominator, you got to put it over 1, okay? I hope we're all clear on that now. Sorry, there was a lot to write. You are not expected to write down these word problems. You just are expected to type or copy the notes in your notebook, okay? Because remember, we say taking notes helps us do better. All right. All right, we're going to do problem 2. Can I have my reader for that one, the person I asked to? Can you come off mute and read me number 2? Hello, where's my problem number 2? I told you who you were. There we go. Good, Daniela. Azalea?
Azalea, Zelia ate 3/8 of a pie, of a pizza pie. She split the rest into 1/8 slices with her friends. How many slices were given out?
All right. So Daniela, remember, good readers, we read it twice. So Azalea ate 3/8 of a pizza pie. She split the rest into 1/8 slices with her friends. How many slices were given out? What fraction do we keep, young lady? We're keeping the 3/8 or the 1/8? She ate. How many slices did she eat?
Keeping 3/8.
Good. So we're going to write on the keep line 3/8. What does the next question say?
The division sign changes into a multiplication sign.
Good. And then the next question?
And the one we flip is the 1/8.
Excellent. And what's another word for flipping the fraction? What's with an R? Good job.
Reciprocal.
Perfect. So Danielle, you're not off the hook yet. You're almost there. We're going to write down the original algorithm. 3/8. What do we start with? The multiplication or division?
The division?
Yep. Divided by. You're going to do the next steps. 1/8. Okay, take it from here. Tell me what I do. What do I keep using what you just did?
So from above, you can see that the one we keep is 3/8. Change the division.
No.
Mute yourself, please. Thank you. Okay, go ahead, Daniela. What do we?
Change the division sign into a multiplication sign.
Good. And what happens to this 1/8? What do we do? What's it called when we flip it?
Reciprocal. I don't know how to pronounce it.
Reciprocal. You got it. What's the reciprocal of 1/8 if I flip that fraction?
8 ones.
8/1. Remember? Now, Daniela, what do we do with the numerators and denominators? Tell me the next step. We're almost there.
8 times 3 is 24, and 8 times 1 is 8.
Okay, so we're going to multiply the numerators, which are 3 and 8, guys, which gives me 24, as Daniela just told us, right?
That leads to 24/8.
Okay, now, can I simplify that? Can I make it smaller? Can I do something to it?
Yes.
What do we do?
Now we divide 8 by 24.
And what do we get?
We get 3.
3 what? What does that represent?
We get 3 pizza slices.
Okay, so we write 3 slices of pizza were given out. Does everyone see how we got that? This is, right? This is an improper fraction. You have to convert it to a mixed number. A fraction is division, like I told you in the beginning of the lesson and on the other 2 problems. Anyone have any questions? Thumbs up if you're with me. I should see everyone behind their camera. This is very important. We're going to be doing this on Monday, and we need some help on this based on our data, based on iReady. This is why we're doing this. Okay, so far it's looking good. Let me just, Justin, I need a camera on. I know you're on a phone, but you don't need anything right now. I need to see your face, sir. And Cynthia, I know your camera's not working, so that would be 3 students with no camera on. All right, I told you who's doing the next one. I'm giving you 5 more seconds to write these notes down. 5, 4, 3, 2, and 1. Let's move on to the next one. Guided problem number 3. Noel, wait, who's doing that one? Hold on. Who's off mute? Stephen Kamos? Is that you? Who's reading this one?
Me, David.
David. All right, David, take it away. What does it got?
The model below represents a division problem. Which equation is represented by the model?
All right, so let's look at this, David. How many whole squares do you see in this picture?
2.
Let's look at this. This is 1. Look at the colors. Watch. Right? Look at the different colors, guys. 2. Right? What's the next one? So now try your answer again. How many whole squares are there?
3.
There's 3, right? 1. We see 3 according to the number line. Do we see that? Everyone see that? So what I'm going to type on my paper is I'm going to type that there are 3 squares, But how many are shaded? 2 and what?
And there would be 2 squares shaded.
With how many left over?
1.
2 and 1 what? What do
Uh,
these slashes represent? How many blank are in a hole?
1.
1 what? 1/2, 1/3, 1/5. What is that?
1/3.
Right. There are 2 and 1/3, right, that are shaded. Does everyone see that? Right? There are 3/3 in a hole, right? Everyone see that there are 3/3, right? There are three of these dotted lines that are broken up equal a whole. So now it's asking you which equation shows this model. We know how many are there in gray. How many gray pieces are there?
And there are at least 7.
Okay, so I'm just going to write this, that there are 7 gray pieces or parts shaded. Okay, now, I don't know what happened over here, but does everyone see that? Now, let's start eliminating. We have 2 and 1/3 that's being divided by 2/3. Here, the bottom shows me that there are these 2/3. We have 2 and 1/3 divided by 2/3 equal 3 and 1/3. So what they're trying to ask you to do is if you had to create a division equation, which one makes this sentence true or this picture true? We know that altogether there are only 7 gray shaded parts. But in the end, we have to come up with, the final answer has to be 2 and 1/3. Right? The final answer has to be 2 and 1/3. So does anyone want to help them out? What we should cross off? Anyone have any ideas before I tell you? Because these are all state questions I'm giving you. Anaya, Daniela, Leanna. Anyone want to come help David out, help a friend out? Yeah, Anaya, let me hear what you have to say. What do you got?
I can help.
Who said I can help?
Me.
Okay. You want to help?
Help me out.
Okay. So what does this person need help with?
So we need to figure out which one of these equations matches the number line and the shaded picture. So do
Okay.
2 and 1/3 divided by 2/3 equal 3 and 1/2. Which one makes no sense here? Let's start there. What do you think?
The model below gives the division of the problem.
What do you think?
Equation is represented by the model.
Let's look at the key though here. We have 2 and 1/3 that are completely shaded in. We know that in 2 and 1/3 there are 7 pieces that make up 2 and 1/3 because 2 times 3 is 6 plus 1 is 7.
Mm-hmm.
So now that I gave you that info, see if you can try. It's a little tricky. First of all, would 3 and 1/3 make any sense?
No, not at all.
So we have a possibility of 3 different answers.
Mm-hmm.
We want our final answer when we do all this math to be equal to 2 and 1/3, or maybe you might have to do something else in order to have that be part of your solution.
Multiplication?
Okay, that's how we would figure out the answer. So do you want to multiply all of these out to figure out which one would be the correct one to model this example?
Yes.
Okay, so how do we convert a mixed number into an improper fraction? What do we do with the whole number? Well, if we have 2 and 1/3, we have to actually multiply the whole number times the denominator and add the numerator. So 2 times 3 is 6 plus 1 is 7/3, right? Remember that? This becomes this
And then
division.
7.
We multiply and then we do the reciprocal of 2/3, which is 3 over 2, right?
Mm-hmm.
So now this would give us 21 over 6. And we already know that this is going to equal 6 times what is 21? About 3, right?
Mhm.
So like, if you do like this, 6 times 21, guys, this would give me 3. We multiply, we get 18. And then we subtract, we get 3. 3 is the numerator that I spoke about before. And the divisor is the denominator. So 3 over 6 is equivalent to the same as 1/2 if I divide by finding the greatest common factor of 3 into both. So 3 divided by 3 is 1, and 6 divided by 3 would give me 2. So that would give me 3.5. That could possibly be right. Now 7 and 1/2, right? 7 over 1, we change that to multiplication, and we do the reciprocal of 3 over 1. This is actually going to give me 21. That doesn't make any sense, so that's goodbye.
So that means it's only B.
Okay, so we keep the 2/3, and then we multiply 3 times 2, which is 6 plus 1 is 7, right? 7 over 3, which is now the same as 3 over 7 when we do the reciprocal.
And now we need to flip.
And we get 6 over 21,
Mm-hmm.
which we just found out was the same as 3.5. So it has to be choice A, right?
Yes.
All right, let's move on to the next one. All right, number 4, Joseph Holman Brisman. Can you please read number 4?
So Anaya has 1 5/8 of a cups of yogurt to make smoothies. Each smoothie uses 1/3 of a cup of yogurt. What is the maximum number of smoothies that Anaya can make with the yogurt?
All right, so help me out here. We're going to use the keep, change, flip method. Instead of me giving you like I gave you up here, what fraction will you keep? You have to do the steps on your own without the help, okay? So now you're going to tell me what fraction do we keep? Walk me through how you would solve this.
We're gonna keep the 1 and the 5/8
Divided by,
divided by the 1/3.
okay? So that would be, I'm just going to, hold on, let me just catch up. We're going to write keep, change, flip. Who else is trying to come in here at this point? Oh, Chidozi, okay. Keep going, Joseph.
So first we have to change this here.
This what? What's this? What's this 1 and 5 equal? What
Fixed
kind of
number.
fraction?
We have
Good,
to turn it into an improper fraction.
good. How do we
before
do that?
divide it. So we have to multiply 1 by 8. That will be 8 plus the 5, which will be 13.
Over.
13/8.
Good. And we call that the MAD method, guys. Multiply, add, and then you keep the denominator. Go ahead.
Then we bring down the division sign.
Do we bring it down or we do something else? Look. What does this say? What does the division sign change to? Okay. So now that you converted, this was an improper fraction, right?
So this one I have to keep it into multiplication.
I mean, mixed number. Go ahead. Go ahead. Keep going.
Since we have to change this division sign, we have to change it into multiplication.
Keep going. I'm listening.
And then we have to multiply the 13/8 by the 1/3 to get our answer.
Hold on. We keep, we change, and we do the reciprocal. 1/3 and 1/3 are not reciprocals. You have to flip the 1/3. Reciprocal.
See, that would be,
So flip this.
yeah.
So the
that
reciprocal.
would be 2/6.
So no, listen. If we have 2/3, Joseph, the reciprocal of that is going to be 3 over 2. I'm going to flip it. If I have 1/6, the reciprocal, I'm going to flip it, will be 6 over 1, Joseph. So now, what is the reciprocal of 1/3?
That would be 3 over 1.
Good. Now what do we do with the numerators?
We have to multiply those.
Good.
So 13 times 3, that's 39.
Good.
And 8 times 1 is 8. So our answer would be 39 over 8.
And that's an improper fraction. Now you're going to look at your answer choices and they're whole numbers. So because this is an improper fraction, we use what operation to make it a mixed number?
See, Division.
Good. We have to now turn this improper fraction into a mixed number or a whole number to get something that our answer choices show, right? Because a fraction means division. So now we're going to divide. Our divisor is 8, and our dividend is 39. How many times does 8 go into 39? About.
I had to guess. Say 4 times
Because 4 times 8 is?
32, which is
Good.
close to 39.
This gives me 7. So remember, the remainder goes as the numerator, and the divisor, which is the outside the house, goes as the denominator. So we got 4 and 7/8. Now, this is what we have, 4 and 7/8. But here's my issue. The maximum number of yogurt. So let's cross off what makes no sense. Is 1 a choice? Does 1 make sense?
Nope.
No. Does 7 make sense?
Nuh-uh.
So now you got a 50-50 chance. Remember, each smoothie uses a 1/3 cup of yogurt. We only have 4 and 7/8. So are we gonna be able to make 4 smoothies according to the recipe, or we're gonna make 5? Because remember,
Since the whole number is 4, then it's choice B.
why is it B and not C? Can you explain why?
See, since we don't have enough to make 5 smoothies, we have to check the whole number, which is 4.
Bam, you said it perfectly. I want you to understand that because when this question was given in 2016, guys, a lot of students, they got distracted and picked 5 because Joseph said it perfectly. You can only make 4 because you don't have enough to make another one. You have 7/8 left over. You need a whole. You need another 1/8 to make it a whole. So that is why we're going to pick B as in boy and not C as in cat. Does everyone see that? Thumbs up if you're with me so far. I know, Adam, you had your hand up. I saw it. I'm just checking my screen. All right. I'm just looking. Shadozi, I'm not sure if you're with me. Heaven, I'm not sure. Yankel? Okay. All right, let's go on to this problem, number 5. The same exact stuff is going to apply. Adam, can you read number 5, Adam?
Okay.
Ardelin?
Ardelin will use a 1/3 gallon pitcher to fill an empty 3/4 gallon water jug. How much water will she need to order to completely fill the water jug?
Ardelin uses a 30-gallon pitcher to fill an empty 3/4 gallon water jug. How much water will she need in order to completely fill the water jug? Remember, good readers reread it at least twice. Okay, use KCF, so talk to me. What do we keep? We have 1/3 and 3/4. Which fraction are we keeping, sir?
1/3
Okay, 1/3 divided by what?
divided by 3/4.
Okay, this is called the KCF method. We're making like 3 boxes here. Okay, walk me through what we do next, sir. I forgot, help us out.
So you put down the 1/3, and then you change the divided thing to a multiplication,
Keep going.
and then you flip the number to 4/3.
Okay, what's another word for flipping? Starts with an R. Do you remember?
I don't know how to say that.
Reciprocal. Can you say that word, reciprocal?
Reciprocal.
Good. Okay, now what do? We have to get the answer. So what am I multiplying?
So you multiply 1 times 4, and I'll give you 4, and then 3 times 4, which is 9.
Wait, 3 times 4 is 9?
No, I mean 3 times 3 is 9.
So 3 times 3, guys, is equal to 9. So the answer is what?
4 not.
Yep, 4/9. So that means, what answer do we pick? You said 4/9. Which answer has what you said?
C.
C. Everyone see that? Keep, change, flip. Because you're going to be working on this on your own in one more problem. I only gave you 2 or 3 exit ticket questions to do. Okay, let's move on. Last one. Michelle, I want you to read this one. It has your name in it, please. Michelle, you're up. Michelle. Earth to Michelle. Michelle, going once, going twice. Okay, Daniel, wait, Michelle, did you unmute yourself? Because there's no camera on. Daniel, can you read this problem, please? Oh, yeah, no, that's not going to work. Okay, all right. Ian, I think I saw your hand up. You want to give it a shot? Let's hear how it sounds in your background noise for your laptop and internet today. Ian? No?
Yeah.
Okay, good. Can you read this problem where it says Michelle?
Michelle has planted seeds in 3/5 of the garden. She used 1/2 pounds of seeds. How many pounds will she use for the entire garden?
Okay, so what are we going to do here, Ian? What method are we using? Keep.
Change, flip. No,
You're
yeah.
right. You got this. Good. Walk me through it. Tell your class what to do. What do we do?
keep 3/5.
Mm-hmm. What?
Um,
We make this, right? We're just going to set it up, right? To division. And then 1/2. Now take it away. What do we do now? Finish. What happens? Do the math. Go. Isabella, you're up. Take over. Keep the 3/5, right? What happens to the division? Isabella? Isabella?
Yes.
Okay. What happens to the division? What does it now become?
Multiply.
Yep, multiplication. And what happens to this 1/2? What does it now become? Flip it. Do the reciprocal. Flip it. Leah, help her out, Leah. What's the reciprocal of 1/2?
I can't say it, but you flip it for the 2 is now where the 1 was, and then the 1 was now where the 2 was. 2/1.
Yeah, 2/1. There you go, girls. All right, now what do we do? One of you ladies, tell me what to do. Leanna Sanchez, what do we do? 3/5 times 2/1. What do we do now?
It's called, it's 1/1 and 1/5.
How did you get to 1 and 1/5? Like, what did you do before you got there?
What was it called? What happened was that I multiplied 3 times, for the numerators, which is the top, which is 3 times 2, and I got 6.
Good.
And 5 times 1, which is the denominators, which is going to be 5.
Good.
So, that's an improper fraction. So we have to make it into a mixed number. So, 5 can go into 6 one time. So I'm going to put that there.
Mm-hmm.
And then, which is going to be 1. So, the top equals, so we used to do top, bottom, and then to the, what's it called? Top, bottom, side. So
Okay.
the mixed number would be 1 and 1/5.
So she needs 1 and 1/5 pounds of seeds. And how you check this to see that this 1 and 1/5 is the same as 6/5, guys, because now Leanna converted the improper fraction to a mixed number by dividing. You're going to take the whole number, which is 1, times the denominator, which is 5, and you're going to add the numerator, which is mad, which gets 6, and you keep it over 5. So 6/5 is equivalent or equal to 1 and 1/5. Okay? Now, I have some extra challenge problems if anyone wants. Wow. If anyone wants to do these extra challenge problems, feel free to do it. It's extra credit. You can make a copy and you can send it to me in the Saturday School Google Classroom. There are, I think I put three problems. There will be an exit ticket. There will be 3 problems. It will be on keep, change, flip. It will be, you purchase 9.5 pints of ice cream. If each guest is served 3/5, What is the greatest number of guests that Natalie can have? Okay, that is what we're going to be doing. You're going to read this problem about David. You're going to use the keep, change, flip method in Samiri. You're going to read this problem about Arlen. You're going to do keep, change, flip. At this point, does anyone have any questions for me? There's a lot of students on. I see someone just came. The class, unfortunately, thanks for coming, but there's only 17 minutes left for you, the person that just arrived.
Okay.
You got to try to come at 9, all right? But thanks for showing up. All right? So what I'm going to do now is you're not allowed to leave until you complete my exit ticket, just like we do in our classroom. I'm going to now allow responses for the exit ticket. Again, you have to remember to keep the first fraction, change the division to multiplication, and the second fraction is the one you flip. You do the reciprocal. The second fraction is the one you do the reciprocal on. Am I understood what we need to do? Does anyone have any problems about what they need to do right now? Because now is the time for you to ask before you show me what you understood. All right. If you have no other questions, I now put the work, do the 3 problems. Once you're done, and I like your score, you're free to go on to your next class. Begin.